I'm going to do a few examples to make formula units of ionic compounds. So beginning with the first one, I have a compound, ionic compound, which is sodium phosphide. So it has two ions, and you can see the IDE. It's written IDE, which means that we're talking about phosphorus ion over here. So sodium is Na in the periodic table. It's in group 1, which means that it has a charge of 1 plus. And phosphide is the negative ion of phosphorus. So phosphorus is in group 5. So group 5 is going to have a 3 minus charge. So these are the charges on the two ions. And then I'm going to use the crisscross method. And if I use the crisscross method, get the 3 over here and the 1 over here. So the formula of the ionic compound would become, Na3. And P would be 1. You just don't write 1 because that's obvious. So this is the formula of sodium phosphide. It's going to be Na3P. Let's do another example. Second example is aluminium nitride. So there is aluminium, and again there's an IDE, which means we're talking about nitrogen over here. So they're going to be two ions, one positive, which is aluminium, and it's in group 3. So group 3 will have a charge of 3 plus. And then you have nitrogen, which is in group 5, and group 5 is going to have a charge of 3 minus. And using the crisscross technique, I'm going to bring this 3 over here and this 3 in 3 plus over here, and the formula that it's going to make is going to be, Al would be 3 and N would be 3. And remember what I told you about crisscross method is this ratio of the ions should be the simplest ratio. Now the ratio according to crisscross is 3:3, and this ratio could be further simplified, and it could be made into Al1 and N1. And again, you just don't write 1. It's obvious. So this 3:3 can be further simplified into 1:1. So the formula should be in the simplest whole number ratio. Let's look at this third example of calcium iodide, and again, when it's iodide followed with the suffix IDE, we're talking about iodine over here. So the formula of calcium iodide is going to be that you're going to have calcium, which is in group 2. So that means it has a charge of positive 2 plus. And I have iodine, which is in group 7. So it has a charge of 1 minus. So I'm going to do the crisscross method and figure out the formula. Just bring the 1 over here, and the 2 goes over there. So the formula comes out to be there's going to be 1 calcium. You don't write the 1, that's obvious. And they're going to be 2 iodide ions. So this is the formula of calcium iodide. The fourth example is of magnesium nitride. And quickly trying to figure out the formula of this, you have magnesium and you have nitride again. The suffix is -ide, so we're talking about nitrogen over here. Magnesium is in group 2, so that's 2 plus. Nitrogen is in group 5, so group 5 is going to have a 3 minus charge. And the formula using the crisscross method is going to be get the 3 over here and the 2 in this position. So the formula comes out to be there is going to be in the formula, they're going to be 3 magnesiums and they're going to be 2 nitride ions. So the ratio in which the 2 ions would exist is 3:2. I'm now going to try and bring in some transition metals. So the formula that I'm going to try and do is iron 3 oxide. And remember, for transition metals, I said that the transition metal ions can have variable charges. So the charge is always mentioned in the formula. So iron 3 means that iron has a charge of 3 plus. Remember, transition metals always form positive ions. So it's Fe3 plus. And the other ion is oxide. Remember, oxide is oxygen. Oxygen is in group 6, so it has a charge of 2 minus. So this is the oxide ion, and using the crisscross method, get the 2 over here and the 3 over here. So the formula or the ratio in which the 2 ions would exist is they're going to be 2 Fe ions, Fe3 plus ions, and they're going to be 3 oxide ions. So this is the formula of iron 3 oxide.